Good morning, our viewers. Welcome on our video today. Today we are looking at chemistry, and we are revising this paper. This paper is out of 100 marks, and this is from 2 work. And these questions, they have a lot of knowledge, and as we said, they keep on repeating these questions in different exam. It can be cut mid-term, end of term, end of year, and even KCSE. You can find these questions in all those exams. And before we do that, we request you to subscribe to our channel if you have not yet subscribed. Like this video and turn on notification. To the subscribers, we really want to thank you guys for the support that you've given us. You can see down here, this channel is growing very fast because of your support, and as we have said, this one is Form 2. Let us go straight to the work. You are told number 1, name 2 apparatus used to scoop solid substance from containers. You can use a spatula or tanks. Number 2, the Bunsen burner produces 2 types of flames. You are told draw a well labeled diagram of the flame produced when the air hole is fully opened. When it is fully opened, it produces non-luminous flame, and it has those zones that you can see we have drawn. It has pale blue zone, greenish blue zone, and then almost colorless zone. Go to question, next question. You are told how can brightness of the flame be reduced? How can we reduce the brightness of the flame? By closing the air hole. Go to question number 2. A mixture of kerosene and water is said to be immiscible. What physical property of the two makes them not to mix thoroughly? That one is density. They vary in density. That is the property. Next, list any 2 methods that can be used to separate this mixture. You can use separating phenyl. Number 2, you can use decantation, and then you can also use a dropper to separate the 2, because one is denser than the other. We go to the next one. What do the lines represented by letter G and J stand for? There was a mistake on this question because we don't have the picture. We go to C. Give the name of a solvent used in paper chromatography. Name of the solvent, that one is propanol or ethanol. Number 4, nitrogen, oxygen, and argon are obtained from liquid air by fractional distillation. That's how you obtain those gases, fractional distillation. Next, state the physical property that makes this possible to separate those gases. They have different boiling points. That's why you can separate them. Next, you are told arrange the 3 gases in order of how they distill, starting with the first. So the first one to distill is nitrogen, then argon, then oxygen, depending on their boiling point. Next, list 2 industrial uses of oxygen gas. This one they repeat it even in KCSE, industrial uses of oxygen. Number 1, in the manufacture of steel. Number 2, welding and cutting of metals. Next, as a reactant in fuel cells. Go to the next question, that is number 5. You're told, what is the chemical name of rust? Hydrated iron 3 oxide. Hydrated iron 3 oxide. Next, apart from sacrificial protection and oiling and greasing, these 2 other methods used to prevent rusting. Other methods that you can use to protect rusting rather than sacrificial protection, we can use alloying. You can also use coating with other metals. We go to the next question. You're told, what are the advantages of rusting? Stage 2, advantages of rusting. Number 1, adding ion nutrient to the soil. Number 2, help destroy worn out iron objects. Next, creation of job opportunities. We go to number 6. What are isotopes? Isotopes are atoms of the same element with the same atomic number but different mass number. We go to the next one. You're told chlorine 35 has a percentage abundance of 75, while the rest is chlorine 37. Calculate the relative atomic mass of the chlorine. That is how you calculate that. Go to number 7. The following are the formula of some ions and their electron configuration. Study them and answer the questions that follow. You have a symbol, and then we have electron configuration, ions, and then electronic configuration. 288 RS 288, and so on and so forth. You can see them clearly. You are told the mass number of ion Q. The mass number of ion Q is 40. Draw its electronic arrangement showing nuclear composition. And this one is very simple. You just look at the electronic configuration, and this is how you draw it. Very simple. You get how many marks? This one, it has 2 marks. 2 marks. Which ion belongs to the same element, and what is the atomic number of the element? We have they belong to the same element. We have V and J. V and J. Let us see them in the table. V and J. V and J. They are like that. Belong to the same element. Belong to the same element, and the atomic number is 15. Next, you are told which 2 elements belong to different periods from the others. That is Q and J. Let us look at Q and J. Q and J. You can see how the electronic configuration is like, and their ion, how it is formed and how it is appearing. That's why we are saying they belong to and different, they belong to different periods from others. Complete the following equations and balance them. Aluminium plus oxygen, you get aluminium oxide. Sodium plus water, you get sodium hydroxide. Then hydrogen gas. Magnesium plus hydrochloric acid, you get magnesium chloride plus hydrogen gas. Then you should know how to balance. You can only know how to balance these questions by doing a lot of practical. You get many equations, then you balance them. The more you try, the better you become. Number 9, write the formula of the following compounds. Calcium nitrate, this is how it is written. Iron 2 oxide, that is how it is written. Manganese 4 oxide, that is how it is written. Zinc carbonate, that is how you write it. Potassium sulfate, that is how you write it. Lead 4 oxide, that is how you write it. Copper hydroxide, that is how you write it. Aluminium phosphate, that is how you write it. Ammonium phosphate. Let's go to number 9. You are told to indicate the colors of the following substances. These ones you need to put them in your mind. I don't know the formula that you will use. Maybe you can go to the laboratory and see them physically. Ask your teacher to give them to you physically so that you can see their color. Copper metal, it is brown. Ask your teacher or the lab technician. Chlorine gas, greenish yellow or green. Magnesium flame, it is white. Potassium flame, that one is purple or lilac. Hot zinc oxide, that one is yellow. Copper 2 oxide, that one is black. Iodine vapor, that one is purple. Sodium flame, that one is yellow. These ones are the basics of chemistry. You need to know the colors and the colors of these metals, because during practical, these are some of the things that they test whether you can remember or whether you can recognize these substances. You can be asked what is the color of the gas produced, what is the color of the metal, or they can tell you to write the equation of the metal with hydrochloric acid. If you don't know it is copper, then, or maybe that metal, and you are given and you don't know the color, then most likely you are going to miss that mark. So it is very important for you to know the colors. Be intentional. Ask the teacher. You write somewhere about these different substances in chemistry, because these are the basics. Number 10, explain the following observations. Chlorine has a larger ionic radius than the atomic radius. Why is it like that? Chlorine has a larger ionic radius than atomic radius. Why? Upon gaining electron, the nuclear attraction reduces or the repulsive forces increases. That's why a chlorine has a larger ionic radius, because it gains than the atomic radius. By gaining, it becomes larger. It becomes larger. We go to the next one. The second ionization energy of magnesium is larger than first ionization energy. Why? When the first electron is lost, the remaining electron experience greater nuclear attraction. That's why the second ionization energy is larger than the first ionization energy. Go to the next one. Atomic radius of potassium is larger than the atomic radius. Why? Atomic radius of potassium is larger than ionic radius. The ions has fewer occupied energy levels than the atom. And we go to the next one. Ionization energy decreases down group 1. Why? Group 1. Do you know the group 1 metals? The group 1 elements, I mean. Do you know them? Ionization energy decreases down as you go down. Why? As the atomic radius increases, the valence electron experiences less nuclear attraction, requiring less energy to remove. That's why ionization energy decreases down group 1. We go to the next one. Balance the following equations. Yeah, there is more questions here for you to do practice. Write them in your book. Write, then you try to balance them. Look for other revision books and get some other questions so that you can be able to balance them. On number 12, the table below shows behavior of metals R, X, Y, and Z. You can see them here: R, X, Y, and Z. Then on the table you are told how they look, their appearance on exposure to air. How do they look, or how do they react when they are exposed to oxygen? Then how do they react when they are reacted with water? Then the last, you are told how they react with the dilute hydrochloric acid. So you are told to arrange the metals in the order of reactivity, starting with the most reactive. So R slowly tarnishes. R on air, it is slowly tarnishes. R on water, it reacts slowly. R on dilute hydrochloric acid, it is very vigorous. X slowly turn white when exposed to air. When reacted with the water, it is vigorous. When it is reacted with the hydrochloric acid, it is violent. Why? When it is exposed to air or oxygen, it does not change. Why? When reacted with the water, does not react. Why? When reacted with the hydrochloric acid, does not react. So this one is like it is not reacting with the 3: air, water, and hydrochloric acid. Then Z, no change on reaction with the oxygen. Then on water, no reaction. Then with the hydrochloric acid, it reacts moderately. So you can easily tell metal which is more reactive, which one is not reactive, because they are reacted with the same. They are reacted with the same substance, and you see how they are reacting. So arrange metals in the order of reactivity, starting with the most reactive. X, you have seen it is very reactive with air, with water, with acid. Then we go from X, we go to R. R, you can also, it has reacted with oxygen, it has also reacted with water, it has also reacted with hydrochloric acid. Then Z, no change, no reaction. Then it reacts moderately, that's why it is becoming number 3. Y does not react with any of them, which means it is the last or the least reactive. Name a metal which is likely to be X. X, can you see X? That one can be potassium. Y, which metal can be Y? No reaction at all. That one is copper or silver. or mercury or